Hey guys, this is video 1.5. We're going to talk about accuracy versus precision in this video. So now we're moving away from kind of classifying and identifying matter. Now we're going to start moving into measurements. Okay, so the first half was dealing with the matter portion, and now the rest of the unit's going to be dealing with measurements. Okay, so kind of a first thing to kind of discuss before we get into calculations and things are, what are measurements in chemistry? Okay, there's four big points that we want to kind of keep track of and kind of remember how measurements differ from numbers. So measurements, here's an example, 3.25 cm, are different than other numbers. Okay, and for example, 3.14159265. Okay, doesn't matter if you have it all in there. So think to yourself, there are two different, two differences with these two numbers. Okay, that I see. What do you notice that's different about these two numbers? So when you take a look at these, one of the biggest things, and my hope is that jumps out to you, is this piece right here. What do we call that in science? When you have letters after a number, what's that called? It's called a unit, right? Whatever type of measure. So measurements have units. That's going to be one of the biggest things that I will harp on all year long. It's a pet peeve of mine. It tells us that, hey, there's some sort of action that has taken place. Okay? Now, the other thing that's different about these numbers is how many numbers do you have here versus the first one? What number is this? This is pi, right? If you remember from math class, that goes on and on and on, they say. How they know that, I don't know. But that just keeps going on and on. Do measurements keep going on and on? No. And that's something we're going to talk about in the upcoming videos and in class and in lab, is these things called significant figures. So guys, the two big differences, measurements have units and they end. Okay, so they're not just, continuing on infinitely. So one thing to remember, kind of the first point that I just already talked about, measurements represent an action by someone with some measuring instrument. Okay, that term instrument just means a tool, some sort of tool that allowed them to get that measurement. So highlight, keyword piece to remember here is action. Okay, it means there was an action, somebody physically had to do it, where something like pi is just a calculation, it's theoretical. The other point to remember with measurements is that they have, because somebody has done it, human has made this, they have built-in uncertainty. i.e., what that means is no measurements are exact. Okay? Built-in uncertainty. They're not going to be exact because somebody who's flawed has made that measurement. Okay, so they're an estimate. And the last thing, you must remember, throughout the entire year, you will lose points on the regents. Each question is worth 1 point. You may have a beautiful setup and do everything correctly, have done all your math correct, everything's perfect, you wrote it neatly, but if you don't put units on the number in the calculation, you just lost the point. You may be absolutely right, but if you do not have the units, you're wrong. So throughout the year, on quizzes, on tests, everything, I will be looking for those. So if you don't have them, I'm going to find it, and I'm going to train you guys to make sure you have your units. So always, 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 always have units. Okay? So those 4 points, how measurements differ from maybe other numbers you're used to. Let's jump in now. Accuracy. This is how close your results are to the accepted or desired value. Okay, so an example would be like hitting a bullseye. okay, when you're aiming for it. That's the key. Okay, you're hitting the mark that you're desiring to aim for. Most experiments, accurate means plus or minus 5%. Okay, so we're going to talk about percent error toward the end of this unit. So if you're within plus or minus 5%, it's considered to be a pretty accurate value. Okay, whereas precision, so accuracy, the other point I want to make sure is one trial. Okay, accuracy is one trial. Precision is how repeatable your results are. So consistency is key here. Or grouping, that's another term. So if you're an archer or a shooter, okay, grouping, how close together they are. So if you have an experiment that has plus or minus 5% as the margin of accuracy, it means the difference between the highest and lowest percent error cannot exceed a range of 10%. Okay, so you got 5 plus 5 on the high side plus 5 on the low side, or minus 5 on the low side. That's a 10% range. So here's an example of everyday life. The highest percent error for an experiment is 7.6%, and the lowest is 5.4%. That means the range is 13, which means that the experiment was not very precise. We will, at some point throughout the year in one of our labs, we might, as a class, kind of look, okay, see how repeatable it was, and we'll talk about why that is. Why is there such a big range? The key in science, think about this in terms of like medicine, right? When a company like Advil, when they're making Advil, they want to make sure it's exact every single time, because if it ranges too much, that could be very damaging results on a patient. Okay, so what I want you guys to do now, you can finish this practice on your own, and you can check your results, and I'll come around and take a look for you in class. All right, I'll see you next time.